It's not. You can't be, I don't know, you'd have to try really hard to top second period because you're talking about Mr. Gressig and his girlfriend, and people just say mean things about his girlfriend. And I was like, we are recording this right now. What? You don't know what the volume of an enclosed gas varies inversely as the pressure. So we talked about this yesterday. Inversely means like y equals some constant over x, but we're talking about volume and pressure. So I think you could say volume equals k over b. And then they give you some information that says if the pressure of a 3.46 liter sample of neon gas at 302 degrees Kelvin is 0.926 atmospheres, what would But the first part, the if part, is giving you the information to solve for K. But they give you extra information on this one because we don't need this temperature. We just need the volume and the pressure. So the volume is 3.46. And at that volume, the pressure is 0.926. And so you just have to do the algebra to solve for the constant, because the constant is different. How much do you think one of those was cost gas or probably too much. Last year, I had my Pi Day song about I wanted a new calculator. So he wrote on my Facebook, I can't believe you're complaining about wanting a new calculator when you have this fancy board behind you. And then he put a link to my board top. And I was like, oh my gosh. How much do you think it cost? $1 million. The link that he said was between $8,000 and $10,000. But maybe they got a school discount or something. I really have no idea, but they showed their ID and got a school discount. So K is not the answer, and there's one on the homework that's very similar to this. I think it's the very last question on the Math Excel homework. If you solve for K and you type that in the box on the homework, it's wrong, because they don't want to know what K is. They want you to solve for the new problem, that what would the volume be at a pressure of 1.52 atmospheres given this K value. So we know that K equals 3.20396, and then the new pressure, is 1.452. So then you take that divided by 1.452, and you should get like 2.207. Did you get that? And apparently you could have done this the chemistry way. I don't know. I do. And then the other two were just kind of dealing with fractional exponents a little bit, talking about domain a little bit. Number 2 says let f of x equal 2x to the negative 1/2. Really easy if you type that in your calculator. What if I asked you to do it without a calculator? Could you do that? If I said f4, 2 times 4 to the negative 1/2. What does the negative 1/2 power mean? What does 1/2 power mean? Square root? What does the negative mean? So like if you had x to the negative 1, remember that means like you move it to the bottom of the fraction. So this means the square root of 4, but it means like in the bottom of the fraction. So if you were doing this, not just typing it in your calculator, that would be like moving the 4 on the bottom and saying 2 over the square root of 4, which gives you, again, really easy with the calculator. If you are thinking about taking calculus next year, calculus, half of the AP exam is without a calculator, and so you have to be aware of some basic algebra rules that sometimes you forget because you get used to writing things. And then what about number 3? Again, without looking at a graph on your calculator or on your computer, do you know what the domain of this would be? X to the 3/2 power. You could think about that. That's like, think about your favorite. You love mixed numbers, right? That's like 1.5. X to the 1.5 power. So that's like saying 1x and then 1/2x. or that's like x times the square root of x. That's the same thing as x to the 3 halves power. I think, for me, I do better with domain when I write it like this than when I write it like this. So this is like a square root function. So what can't you have in the square root function? 0. That's not true. You can take the square root of 0. It's 0. What can't you take the square root of? Negative numbers. So which one of these is your answer? What letter? Okay. B, as in binomial. B should be B. Because 0 is allowed, and everything bigger than 0, because you can't take the square root of negative. What about homework questions? Questions there. It's just like the one we just did. But I'll look at it. I know, because I put saved it. So important, I know. So how much do you think? So look at how much the pen costs. While you're not taking it. You're already around the site, so funny story, yesterday I tried to get on my Chromebook to do these problems so that I could have a better complete in the class. And it was blocked, and then I had to go to Jared and he had to unblock the site. Like, you could get on it on your Chromebook, but I couldn't get on it. Isn't that weird? So he had to unblock it for me. But I'm just, it's always red and I pick up it. This is just like the one on the discussion. It says, if the temperature is constant, the pressure of a gas in a container varies inversely as the volume of the container. Only now its pressure varies inversely as volume. Wasn't Boyle's law the other way? Volume varies inversely to pressure. And then again, just like the one on the discussion question, they give you the pressure is 40 pounds per square foot, and the volume is 7 cubic feet. And then you solve for K. So if you multiply 7 over there, you get that K is 280. But again, you're not going to plug 280 in there because they don't ask you what K is. They ask you what is the pressure in a container with 1 cubic feet. So now you can set up the problem where K is 280, and you set up the volume as 1.5 cubic feet. And if your numbers are different, you would use different numbers, but that's what you would type in there. So in these problems, you have to set up the equation, solve for K, then solve what you're looking for. So it's kind of like a 3-step problem. That's what I think of. Other questions? Okay. We're going to move on to section 2.3 today, but we're going to spend a couple days on it, and then we're going to do 2.4, and then we're going to have a test, because this chapter's kind of long, and I like to break it up halfway through, which means we're going to have a test next week. Guess how many kids were in my calculus class today? One person! And I talked to her because I was angry at the seniors. And so I talked to her about all their stuff. That's funny. Brenda actually talked in class today. Normally she doesn't, so. I ate first place 3. One. Okay, so some of the stuff we reviewed today is like in behavior. I'm pretty sure you did in behavior in algebra 2. Finding zeros in a function, I'm pretty sure you did that. Talking about the behavior of the zeros, that might be the part that goes a little more in depth than what you did in algebra 2, and we'll even do more tomorrow with zeros. Talking about multiplicity, you know what we're talking about multiplicity in okay, boys, are you done on your computers? Or, So, let's see if we can come up with this. When I graph x squared, it looks like this, right? When I graph just x cubed, it just looks like the S shape, right? But if I had a bunch of other stuff with x cubed, like x cubed plus 2x squared minus 7x plus 2, it could look like this. Let's go with it. So, based on the degree, we can tell how many turning points a graph can have and how many zeros a graph can have. And I think we can figure it out from here. X squared has how many turning points? 1 turning point. X cubed could have how many turning points? 2. So the rule is that a polynomial function of degree n has at most how many turning points compared to the degree? So x squared has n minus 1, right? It's 1 less. X squared has 1 turning point. X cubed could have 2. Here's kind of the important part there. It says at most, which means it could have less than that. X cubed could have no turning points. But it has at most n minus 1 turning points. And at most in zeros. And think about x squared. We know that x squared could have 2 answers. It could have 1 answer, or it could have no real solution. But it never has more than 2 solutions. So sometimes they give you graphs and they make you match them up. And one thing you can do to help match them up is look at the degrees. So like if I gave you something like this, oh, that was okay. How many turning points does that graph have? 4, right? 1, 2, 3, 4, which means this could be at most what degree of a function? At least. Right? Because it could be like x to the 10th, right? So this could be it has to be at least a 5th degree polynomial. Alright, so that's what it means by that. We'll talk about this more when we get to the fundamental theorem of algebra, which talks about exactly how many zeros a function has. Okay? So the beginning of your homework looks just like this, except for it's online, so it's multiple choice, so it's easier to graph by hand. Again, talking about these transformations, but sometimes we don't graph x cubed as often as we should, so I think it's good to talk about this. Just good old x cubed is our favorite odd function, hopefully, that when you graph it, you go, it's odd because this side's positive and this side's negative. I plug 2 in there, it goes all the way up to 8, so it goes really quickly. X cubed is a really cool function because it's increasing the whole time, even though it has that weird little term there in the middle. So on your homework today, you have a couple graphs that you just have to pick what the transformation graph is. So again, think about this. What does this minus 3 on the inside mean is doing to my graph? To the right 3, and what's this 2 on the outside mean? Stretching it by a factor of 2, right? So it should look thinner. So if I was going to graph this, I would go right 3. So instead of 0, 0, it would start over here at 3. And when I plug 1 in there now, it's going to be twice as big. So when I go over 1, I'm now going to go up 2. When I go back 1, I'm going to go down 2. And think about that next point. Normally when you plug 2 in, you get 2 to the 3rd is 8. When you plug in 2 over from there, it's going to go up twice as high. It's going to go up to 16. So it almost looks like it's going straight up and straight down because it's rising faster. Again, the fact there's multiple choice, I think, makes that less terrible to do. But definitely feel free to zoom in on those graphs. Okay. End behavior. When we talk about end behavior for graphs, when we're graphing these by hand, it's really important to know which way the arrows are going to go. And it all depends on if your function has an odd degree or an even degree, and the leading coefficient, whether it's positive or negative. So I like to start with even. I don't know why I wrote it on the bottom. But even's really easy because if you think about parabolas, right? When x squared, when that's positive, what do you know about the arrows of that parabola? They both up. And when it's negative x squared, what do you know about the arrows? They both point down, right? So if you're just using this to sketch your graph, like it's easy to say, well, if it's a positive leading coefficient and it's even, I know both my arrows will point up, or I know both my arrows will point down if that leading coefficient is negative. That works for any even function, x to the 4th, x to the 6th, x to the 8th. Whatever happens in the middle happens, but the arrows will always be pointing in the same direction. But if they ask you to describe the end behavior, you have to write it out with infinity. Let me see if you remember this from last year. So we say, as x approaches infinity, f of x approaches something, y value. And as x approaches negative infinity, f of x approaches something. Did you write it out like that? So this is how you write it every time. All that changes is the in part, so that's why I write it in the blank. You have to write that every time. And if you know both arrows point up, that means that it doesn't matter where x is going, the y values are both going towards infinity. So this would be that f of x approaches. And if I do the same thing over here, as x approaches infinity, f of x approaches something, and as x approaches negative infinity, f of x approaches. When it's a negative even degree function, both point down, so that means that both of these go towards negative infinity. So if it says describe the end behavior, you have to write it out like that. Odd functions always have arrows that go in opposite directions. So I always say it's like this note. I don't really know this is how this fancy notes, but that's how I Mr. Aggressive can dance for you. He just had you watch Star Wars or whatever. Hung up whatever that thing was this month. Right, so odd I think of x cubed. I know on x cubed the positive side goes up and the negative side goes down. So these will always be different directions. If the leading coefficient is positive, the positive side goes up like this. So it's going to go to infinity. But the negative side, or the left side of my graph, is going to stay negative, and it's going to go towards negative infinity. And then you just flip it if the leading coefficient is negative. So one more time here. I'm doing better. In second hour, I kept leaving off my negative infinity every time. So on this one, if it's negative, then the right side goes down and the left side goes up. So it's the opposite. So as x gets bigger, y actually gets smaller. And as x gets smaller, y gets bigger. On your test next week, there will definitely be a couple questions that I ask you to describe the behavior, and you have to write it out. Questions about that? Pretty helpful in the graphic without a calculator to know that. There we go. Alright, so I don't know if this is something you talked about in Algebra 2, maybe it's something that you noticed. But when you have a zero, what happens at the x-axis depends on the exponent that is on that zero. So think about x squared, that would be an even function. When you graph x squared, the zero is at 0, right? When you graph x cubed, it also has a 0 at 0. What would you say is the difference between the 0 at 0 on x squared and the 0 at 0 on x cubed? Vertex, I think that's what you mean, right? Yes, and this one doesn't have a vertex, right? What if I did this? What if I told you this one had an even power on it, and this 0 and this 0 were odd? Because you're right, this one is a vertex and this isn't a vertex. But this could be a polynomial function. And what if I told you that this 0 had an odd power on it, this 0 had an odd power on it, and this 0 had an even power on it. Could you tell me something else you noticed about the difference between an even one and an odd one? Totally. An odd 0, if it's odd at the x-axis, it will always cross the line. And if it's an even one, like x squared or like this one, it won't cross. It'll come down and touch, or if it was underneath it, it'll come up and touch and come back down. So when you look at a graph, you can tell about the zeros by looking at whether it touches or it crosses. So if it is even, then we say we know that the 0 will just touch the x-axis at the x-intercept. But if it's odd, and we'll talk about this more tomorrow when we talk about multiplicity, if it's odd, it'll always cross through the x-axis at those. Okay? So today we're really just kind of focusing on zeros that are hopefully pretty easy to find, and in behavior, talking about the degree and the leading coefficient. Tomorrow we'll talk more about multiplicity, and we'll talk more about graphing them, maybe a little bit more difficult ones. But if I asked you to find the zeros of this, what would you do to find the zeros of that? Do you have to multiply all that out to find the zeros? Yeah, like it's supposed to be like set up for you here. They've already factored it for you, so the zeros are just like thinking about setting that equal to 0. So you just solve each of the factors, right? So you can just look at this and you can say the zeros are at 1, are at -2, and are at -3 because I'm just solving that equation. Just kind of relating it back up here, the exponent on all these zeros right now, like all of those are just to the power of 1, so all of those would just cross through the x-axis. But if there was a 2 right there on the x plus 3, that means at -3, it would just touch and it wouldn't cross. So that's what I mean about touching and crossing. It's about like what the exponent is on this. Okay, so that's the zeros. In behavior, you got to figure out the degree of this to do the in behavior. Do you need to multiply this all out to find the degree of it? What would the degree of this be, Alex? What do you think? Do you think it's 1? And what do you think? How did you get 3? Because if you multiply just the x's together, x times x times x, wouldn't that be x to the third? So you don't have to multiply it all out, but you have to at least think what would it be if you multiplied x. Alright? So if it's x to the third, that's odd, that's a leading coefficient, it's positive. So by our test next week, you have to know these rules if you don't already know them. That I can say, right, that's the same every time. That's why I just kind of do it really quickly. If it's odd and it's positive, then the positive stays positive, the negative stays negative. So you haven't already tried the second one, see if you could do, I guess, number 3. What are the zeros of that, and what do you think that it should be? So this one, -1. And even though there's a cube out here, you can take the cube root of 0, it's still 0. You still get x equals 4. Dylan, what would the degree be of this one? Because this is x to the third, and then we have 2x, so like our leading term would be 2x to the fourth. Right? And so Alex was asking, like, how would I know if it's negative? That was a -2 in front of that. When you multiply that together, that would make -2x to the fourth. So you always want to think about what that would be. So that's even and positive. That's a lot of work. Which means they're both pointing up. So you would say infinity. Questions on that? Have two worthies, but to me it's like the same stuff, so you tell me if you want to do it more. These are not factored, but notice it doesn't say find the zeros, it just says find the in behavior. which means you can just look at it for the degrees and the leading coefficient, right? You okay with that? You want me to do these? But I want to do. So I know I put at least one of these on the homework that it says find the zeros of the function algebraically, which means you should be able to factor this. So what could you factor out of this? I could take out 5x, and I would be left with x squared minus x minus 2. And then I can factor again. Multiplying 2, subtracting a1, negative 2, positive 1. So this one is just making you factor it out. But then you could do the same thing, as you could just set each one equal to 0, and you get x equals 0, x equals 2, x equals negative 1. Questions? Okay, so you have some homework online, just like yesterday. I think there's like 6-ish problems. I can't remember exactly. But then I also have a little paper for you. So just real quick on this. The first four here, you're just matching the graph with the equation. Maybe you look at these, like look at A and look at C. You're like, oh no, they have the same end behavior. And look at B and look at D. Oh no, they have the same end behavior. You should be able to look at the y-intercepts to help you figure out which one is which on those. What was the y-intercept of number 1D? How could you find the y-intercept pretty easily? What does it mean to find the y-intercept? Because the y-intercept is just when x equals 0, so on a polynomial function, the y-intercept is just a constant at the end. So you should be able to figure out the difference between them based on their y-intercepts and their end behavior. Alright, so you shouldn't have to do a lot of work on those. And then number 5 and number 6 are just like the ones we just did, where you have to state the zeros and end behavior. And then number 7 is a story problem that I want you to try to set up or solve anything using the right function. So this plus the plus yesterday, you look at that stuff yesterday as well. Again, we're looking at our class.